We can get them by cutting a cone. So today we're going to talk about a circle. We can get a circle by cutting a cone parallel to the, we can think about the base of the cone. We cut a cone parallel to its base, we get the shape that gets traced out is the circle. And we'll talk about parabolas. If we cut a cone parallel to the side of the cone, then we get a parabola traced out. And an ellipse is, we can think of it kind of like a slanted circle. And hyperbolas, if we cut through both sides of the cone, if you go further in math, you'll figure out why cone. We'll talk about why cones have two pieces. If you cut shape that goes through the plane that goes through the two pieces of the cone, you get hyperbolas, and hyperbolas come in pairs. So we'll talk about all of those over the course of the unit. Today we're going to talk about circles. So I just wanted to show you why we call them conic sections, where that term comes from. What we're going to do today is we're going to give a different kind of definition of a circle, or give a definition of a circle, and we're going to use that definition to solve different kinds of problems. And that's really what we're going to do with all the different shapes, is talk about how we're going to define them and use that definition to write equations and then solve problems that have to do with these equations. So our circle, the definition that we're going to work with is, we're going to get a fancy new word here. A locus. A locus is just a set of points that have some kind of property. So the locus of points xy that are equidistant from some given point hk. So that's how we're going to define a circle. Locus just means a set of points that have some kind of property. What do we call this given point that we're talking about for our circle? The center. HK is a center. And it says all these points are equidistant from the center. What do we call that distance for a circle? The radius. And our equation for a circle comes from this idea that the points are the same distance from the center. So we might guess that what we're going to talk about has to do with the distance formula. So do you remember the distance formula? Square root. Remember how it works? x2 minus x1 squared plus y2 minus y1 squared. If we have 2 points, x1, y1, and x2, y2, that's our distance formula. Our equation for the circle comes from the distance formula. Our distance is the radius, and one of our points is going to be the center. So using that idea, we can write our standard equation of a circle. So we're good with all of this. So our standard equation and pretty much everything that we do in this section and everything we do in this chapter is going to have to do with these standard equations. We'll come up with standard equations of all of our shapes. X minus h squared plus y minus k squared equals r squared. And our center is at the point hk, and radius equals r. And this comes directly from the distance formula. If we took the square root of both sides of this equation, we would end up with a distance formula where our radius is our distance. H and k is 1 point, and x and y are just some point that is on the circle. So everything's going to come back to this equation of our circle. All right, questions there so far? So what I want to do today is just go through a few examples of the types of problems that we're going to solve with the standard equation, the types of problems that you might be asked that have to do with circles. All right, so the first one, we want the equation of a circle. With center -1, -4, and it goes through the point 5, 7. So we want to write the equation of the circle. So what is this question really asking us to do? Other than write the equation, what do we need to write the equation? We need to find, well, let's think about what we have. What is the center, what part of our equation does this give us? What part of this equation does this give us? That gives us h and k. So from our equation, what are we missing? What piece of information do we need? We need the radius. So the question is really asking us to find the radius. That's where our work is going to be. So we want to find the radius. How are we going to do it? We can either plug it into our equation, because what piece of the equation does this 5, 7 give us? That's an x and a y. So we can think about the problem two different ways. We can either plug everything that we have into our equation of our circle, or we can use the distance formula. The distance from the center to this point is going to give us our radius, or plug everything into this equation and solve for the radius. They're really the same thing, because this equation comes from the distance formula. So we can plug these numbers into our formula, and we get our radius. So let's plug this in. I'm just going to plug it straight in here. So this tells me r squared equals x minus h. So 5 minus -1 squared plus y minus k. So 7 minus -4 squared. So r squared equals 5 minus -1 is 6, so we get 36, and 7 minus -4 is 11 squared. 36 plus 121. So r squared is 157. And that's what we need for our equation. We could say that the radius equals the square root of 157 if we needed to know the radius. But all we need for our equation is r squared. So now we can write our equation. X minus h, so x plus 1 squared plus y minus k, y plus 4 squared equals r squared, 157. And there's our equation. So we've done, over the course of the year, we've done quite a few problems like this where we plug our points into an equation that we know. Or we could use a distance formula. For this problem, they turn out to be the same. All right, questions there? All right, let's add another little twist here. So the endpoints of the diameter of our circle are 3, 4, and -5, -6. We want the equation of the circle. We got a little bit more to do here, not a lot. So what do we need here? What pieces of information do we need to write our equation of our circle? We need the center and the radius. How do we find the center? If we have the endpoints of a diameter. It's the middle, right? The center is the midpoint of these 2 points. And like Olivia said, also, if we know the length of the diameter, the distance between the points, and divide it by 2, we get the radius. So the radius is half the length of the diameter. So we have all of this information we can get from our 2 points. Our center is our midpoint, and the radius is half the diameter. Do we remember how to find a midpoint between 2 points? All this coordinate geometry stuff coming back here. The midpoints, we get the point x1 plus x2 divided by 2, the average, and y1 plus y2 divided by 2. So the midpoint of between 2 points, x1, y1, and x2, y2. Take the average of the x coordinates, the average of the y coordinates. That gives us the middle of each one. So that's going to give us our radius, our center. So our center is going to be at the point 3 plus -5 divided by 2, and 4 plus -6 divided by 2. So I get the point -1, -1 for my center. And the radius is half the diameter. We find the length of the diameter using the distance formula. So I'm going to say the diameter d is the square root of -5 minus 3 using the distance formula squared plus -6 minus 4 squared. So -5 minus 3, I get -8 squared, so I get the square root of 64, and -6 minus 4 is -10, and we square that, we get 100. Square root of 164, and I'm going to make this nice and neat. Square root of 164 in simple radical form is 2 square root 41. And so the radius is half of this, so the radius is just going to be the square root of 41. And now we can write our equation. X plus 1, x minus h squared, plus y plus 1, y minus k squared equals r squared, 41. And that would be our equation of our circle. All right, questions there? All right, let's look at another example. This one's my favorite. We get a visit from an old friend in this problem. So we want the standard equation of this circle: 9x squared plus 9y squared plus 54x minus 36y plus 17 equals 0. So this is a circle, but we want the standard equation. And our standard equation, I just want to write it here to contrast. Do we remember a technique, something that we've done in the past, where we have something with a 9x squared, a 54x, and a number, and we end up with something that looks like x minus h squared, some perfect square? Remember doing something like that? Change this into something that looks like this. What we have to do here is complete the square twice. Once for the x part and once for the y part, to get them into the form of a perfect square. So this will come up a lot in this chapter. When we're talking about conic section, we're going to be completing the square a lot to get standard equations of conic sections. So what I want to do here is we'll group the x terms and group the y terms and put the number that's by itself on the right hand side. So I have 9x squared plus 54x. That's one piece that we're going to complete the square on. And we get a 9y squared minus 36y. Complete the square on that part equals negative 17. So we're going to complete the square on each set of parentheses. Complete the square on the x piece and the y piece. So what's the first thing we want to do here before we complete the square? What do we do? We don't want to take out the x, but we don't want anything in front of the x. We want to factor out that 9. We don't want this coefficient in front of the x. So we get 9 x squared plus 6x plus 9y squared minus 4y equals negative 17. And now we're going to complete the square here. So I get a 9 x squared plus 6x. And what we're going to do when we complete the square here is whatever I add to the left side, I'm going to add to the right side. So I keep everything the same. Do you remember how to complete the square? What do I do here? Divide by 2 and square. So 6 divided by 2 is 3. We square that and we get a 9. Plus 9, we're going to complete the square here. 9y squared minus 4y divided by 2. So we get negative 2. Square that and we get 4. And whatever we add over here, we want to add over here. Here's where we have to be careful. That 9 is distributing, and that 9 is distributing. So on this side, I end up adding 81 and 36. So I'm going to add an 81 and a 36 on this side. So I have to remember that 9 is being distributed to everything in the parentheses here. All right, now we're close. We get 9. This factors to x plus 3 squared plus 9 y minus 4 squared. This, if I add all these together, I get 100. And then to get our standard form, I don't want these 9s in front of the x's and y's, so I get x plus 3 squared plus y minus 4 squared equals 100 ninths. Just divide everything by 9. So now I have a circle, and if the problem asks us, we know that the center is, where's the center of the circle? Where is it? Negative 3, 4. And the radius? Should it be 2? Should it be 2? Yeah, I think you're right. That should be a 2. And that should be a 2. So what should this be? 2 also? And a radius. What is it? 10/3. So we complete square twice. Simplify everything down. Make sure we don't make a mistake when we complete the square. And then we can find our center, we can find our equation and our center and our radius. And if you go on, if we're talking about shapes in solid shapes in 3 dimensions, the equation of a sphere, for example, and you wanted the standard equation of a sphere, you have to complete the square 3 times. Once for x, once for y, and once for z. Same process. All right, we good there? Okay, the last one, I don't want to go through the entire thing. I just want to talk about how we would set this kind of problem up. What if the problem asks us to find the x and the y intercepts of this circle, x minus 5 squared plus y plus 2 squared equals 21. So before we solve this problem, let's think about the possibilities. So here are my coordinates. How many possibilities do we have for x-intercepts? How many could we possibly have? What's the most we could have for a circle? 2, right? The circle could look like that. We could possibly have 2 x-intercepts. What's another possibility? 0. Our circle could look like that. Do we have another possibility? 1. If our circle looked like that and has touched the axis. And the same is true for the y-intercepts. I could have 2, 0, or 1 y-intercept. All right, so to find the x-intercepts of this equation, what do we do?
Would you have 4 intercepts?
Right, so you'd have 2 x's and 2 y's.
Oh,
yeah, so we can have 2 x's and 2 y's. So how do we find the x-intercepts? What equals 0? Y. Set y equals 0. And we solve for x. And the reason we get 2, 1, or 0 solutions is when we plug in y equals 0, I get a quadratic equation, and we end up with a possibility of 2 answers, a plus and a minus square root. We can end up with just 1 answer. Or, how would we get no intercepts? If we're solving a quadratic and we're taking the square root, what would tell us we have no intercepts? Square root of a negative, right? We'd get an imaginary number. That would tell us we have no intercepts there. And then for our y-intercepts, how do we find our y-intercepts? Set x equal to 0. And we've done this kind of thing a lot of times over the course of the year where we want to find our intercepts. X-intercept is when y equals 0, y-intercept is when x equals 0. And we have possibility of 2, 1, or 0 y-intercepts, depending on where the circle is situated. So I'm not going to go through the solution, but that would be the process for this one. And with the circles, we won't do it as much, but starting with parabolas on block day, graphing is going to be something that is plays a pretty big part in this chapter. So we're going to be graphing these conic sections from the information that we get from our equations. All right, questions? Okay. All right, there you go.